Hi, I'm Chris Bainham-Hughes. I'm a Customer Innovation Advocate at Red Hat Open Innovation Labs. And today I'm here with Tim Beattie, our Global Head of Product, and we're going to walk the virtual walls. Now, remote working has introduced a number of challenges for a lot of companies, but actually when you really get under the surface of it, it's the same problems that they had in the real world, in the non-virtual world. So any problems with culture and practices rather than technology, those are amplified. So Tim, could we talk a bit about what we're going to do today with these Walk the Walls?
Yeah, sure. So in Open Innovation Labs, we have this practice called Walk the Walls, which is where we have a good old-fashioned conversation and people can walk the walls, look at artifacts and information radiators and learn lots of information about teams, products and next steps and approaches. Today we're going to connect with our awesome team from all over EMEA. Hi folks. And they're going to virtually walk the walls with us and show them some of the artifacts that they've used with their customers. So first up, we're going to talk to Shabnor, who's one of our open leadership coaches, who's going to talk to us a little bit about the open organization.
Hi. An open organization can be defined as one that engages participative communities both internally and externally, one that responds to opportunities more quickly and has access to resources and talent also outside the organization. And most importantly, and of course one of my favorite, is that open organizations inspire, motivate, and empower people at all levels to act with accountability. So while every organization is different and therefore every example of an open organization is unique, we believe that these 5 community-evolved characteristics serve as a basic condition for openness in most contexts. Let me introduce you to these 5 open organization characteristics. Number 1 is transparency. In open organizations, work is transparent to the extent that anyone can monitor or assess a project's progress throughout its development. It is open to observation and potential revision if necessary. 2, inclusivity. Open organizations not only welcome diverse viewpoints, but also implement specific mechanisms for inviting multiple perspectives into dialogue whenever and wherever possible. 3, adaptability. Open organizations are flexible and resilient. People are not afraid to make mistakes and are more willing to take calculated risks. In this way, open organizations are fundamentally oriented towards continuous engagement and learning. 4, collaboration. Work in open organization involves by default multiple parties. Participants believe that joint work produces better, even more effective and sustainable outcomes, and they specifically seek to involve others in their efforts. 5, community. Open organizations are communal by nature. Participation is guided by purpose and shared values in open organization. And these values, more so than the geographical locations or hierarchical positions, help determine the organization's boundaries and conditions of participation. So that's open organization for you in a nutshell. Thank you.
Wow, thanks Shabnor. That was really fantastic. I love the open org characteristics, and we really use those as accelerators in what we do. So Tim, what's next?
Cool. So usually the very first practice that we do when we're forming a team in a virtual residency is the social contract. And to show us and tell us about the social contract, let's hear from Ilaria, one of our engagement leads in Italy.
Social contract, that is like defining in a document the ground rule that we want to have in terms of behaviors among us, expectations. So we give to the team a name, and then we agree on the ground rule and we sign it. And the document is displayed because it's relevant and make us accountable of it, and then we go back only when it's relevant, for example during a retrospective. If you want to see a couple of examples, you have them on the screen, and for example there are these 3, and if I zoom in I have example of challenge the status quo or listen and learn, be on time. These are the things that are relevant to the team. Back to you, Tim and Chris.
Awesome, thank you, Ilaria. Such a good practice, absolutely love it, and the way it sets the team up for success is just brilliant.
Yeah, absolutely. So we've now heard about how we're going to work together and agreed that. Now let's look at what we're actually going to achieve. What are we going to build? So we're going to go over to Jorge in Spain, and he's going to talk to us about target outcomes.
Hola Tim, hola Chris. So Chris, you're almost right. But I'm going to be talking about 2 practices instead of just one. Target outcomes and priority sliders. So target outcomes, it is a very effective tool to capture and articulate the goals a team wants to deliver, while on the other hand, both target outcomes and priority sliders help achieving alignment and shared understanding across stakeholders. They usually work very well together, so let's deep dive into them.
So, let's take a closer look at target outcomes. As I was saying, it is a tool to capture and articulate the goals and outcomes a team is aiming to deliver. They can be used to summarize the finding from other discovery practices. Usually a couple of sentences are enough, and they should be publicly displayed for anyone, a team member or a stakeholder, to regularly reference them. So, why do we use them? Well, because they help achieving alignment and focus across stakeholder and team members, because they provide a visual reminder on the current outcome of focus and can be used to help with prioritization and filtering of upcoming work items. Usually, it is a very common mistake to confuse outcome with output. So, let me put it this way. Outcome is the result, is the definition and measure of success, while output is the work required to reach the outcome. They should be measurable and can be revisited and updated as often as necessary. So here in the screen, we can see a couple of real examples. The first one says, increase software quality by having 100% of the tests automated and having more than 90% code coverage. The other says, build a new platform that allows developers to onboard new applications in less than 2 hours. So we can see they are both measurable and focus on results and not outputs. And that's it. Let's now go to the other great practice. So, let's talk about priority sliders. The team has to select a set of topics, dimensions, or areas and give them a score, usually through a voting or consensus exercise. The score is relatively prioritized against each other. This means no dimensions can have the same score, and the higher score means the higher priority. In this particular example, there are 8 dimensions or focus areas, and the scores range from 1 to 8. You can see a lot of colorful dots because that was the voting mechanism used by the team. In this case, the lowest priorities were the test completeness and the functional completeness. And the highest priorities focus areas were operational readiness, learning, and experience design. So, maybe you are wondering, why do we use it? Well, because it facilitates conversations about relative priorities and focuses on common activities. It also enables an alignment and consensus on focus areas and provides clarification across stakeholders. We can also use it as a filtering mechanism for later prioritization, for example, product backlog items. When in doubt about a backlog item, we can always check on the priority slider. Finally, it increases the autonomy of teams. It helps to keep the team on the rails. Now, let me run you through a real-world example. Once, during a residency, the product owner wanted to make the product production ready. But that was not one of the top priorities agreed with the team at the beginning. So as a team, we change the priorities accordingly after discussing it with the product owner. And those changes not only got reflected in the priority slider, but in the product backlog due to a reprioritization and in the emerging architecture as well, because we had to evolve it to make it production ready. It triggered conversations about backlog reprioritization and scope. So I think this is a good example of how using priority sliders can help to provide clarification and help to filter and prioritize the backlog. Back to you guys.
Brilliant. Thank you so much, Jorge. I see you managed to get a second practice in there with priority sliders. They work so well with target outcomes. Next up, we're going to explore some of our discovery practices and ask the question, why? Why are we here? What problems are we trying to solve? Who are we trying to solve them for? And to help us with this, we're going to go back to Ilaria over in Italy, who's going to tell us a little bit about impact mapping.
Impact mapping is a practice that helps to connect output with outcome. We started from the target outcome previously, and this is helping stakeholders to narrow down the goal and the reason why they are willing to do an initiative. So the beginning is really something that helps to do a conversation, generating idea for the goal and the why, and measure to be sure that everyone is on the same page. After this, the stakeholder and the team with their conversation can move into the who, defining which are the actors that can help to achieve the goal or prevent to achieve the goal. And after this important step, the next one is to understand the how. That means clarify which are the behavior that they want to change in the actors to achieve the goal. After behaviors and the impact that they want to have on those actors, the last step is to identify the what that are the output. This means you have a list of deliverables that can be connected because you assume that developing those functionality, you have the possibility to achieve the goal. So you do assumption and you give also the possibility, the stakeholder, to vote which are the most valuable deliverable that can help to achieve the goal quicker. So you do an assumption at the beginning and then you need to go back and prove along the journey. Back to you, Chris and team. Thank you.
Brilliant. Thanks, Ilaria. I love that practice, especially the way that it builds purpose within the team, but also allows everybody to surface assumptions about what we're actually building so we get to build the right thing. Very important. Okay, so next practice is superb. It's called event storming. I love it. You'll love it. Donal definitely loves it. So over to you, Donal.
Cheers, Tim and Chris. So the practice I'm going to take us through now is a practice called event storming. Event storming is a really, really cool technique that allows us to explore a business domain or a problem in a really kind of colourful way with lots of different colour post-its and stickies. So let's take a look at one. So what we have here is an event storm from a residency that we just finished. This was a distributed virtual residency with team members distributed all across the globe and in different time zones. So obviously we couldn't come together into a physical space to be able to do the event storm, so hence we used an online collaboration tool to build it out. So let's take a look at some of the pieces in a bit more detail. Over here we have the key to the event storm, and the event storm follows a very specific color-coded pattern, all hinging on this thing in the middle called the event. And an event, in the simplest terms possible, is just something that happened in the past that people care about. So for example, something like order submitted or payment completed could be examples of events. When we build out an event storm, we always try to frame it. We use an additional part of the notation that we've invented at the Open Innovation Labs called the Friends notation, TOW, the one where. So the one where should show an example that we're trying to process map using this tool. Once we've got our the one where, we then add in some of the other pieces of the puzzle, such as the command, which is the desire or the action to go and do something, as well as the system in which that will receive that command and propagate the event. An event storm should tell a story from left to right. And the simplest way to read it is a user might like to do something or try something out. So for example, imagine you went onto a website and you saw an item was on sale. That piece of information might give you an idea that you want to go and do something, such as add it to your basket. That add to basket command would have to be issued to a system, which will propagate an event, such as the basket updating, which would therefore change some of the data on the screen or perhaps change some data in a backend. With this additional change in the thing that's viewed to the user or update to the data model, then another or a subsequent command could then be issued. And in this way, we get this nice story moving from left to right, framed within the one where that we're trying to explain. So let's take a look at what we did for the WHO. So we started with some things like LXP opened. LXP was the shorthand for the Learning Experience Platform. And we used this kind of as the initial event from where we're starting the flow. So the LXP opened was propagated through to the sign me up command, because this was an onboarding flow that we were trying to model out. So what was the information that was needed in order to be able to present a sign-up form? So things like terms and conditions, GDPR, and then with these on display, the user might agree to the terms and conditions. This information would have to be captured somewhere, and so we called this thing the Profile Combobulator. The reason why we called it a combobulator was because we weren't sure what to call it just yet, but we knew that it was taking information from different sources and aggregating them together into this new meaningful object. As we kind of glance along, we can see various other systems and actions interacting throughout. So as part of this onboarding process, someone was able to sign up, maybe configure their profile by selecting things that they were interested in, such as skills or topics. Let's zoom in on this section of the event storm for a moment. In this section, up to this point, a user has just gone through a kind of standard registration flow, and they're now about to start configuring their profile. The reason why they're doing this is to give a more informed suggestion as to topics or courses that the learner might be interested in doing. So for example, over here, the user is going to submit some topic of interest. So imagine in a UI, there are some things on the screen, such as a bunch of buttons or tabs with labels or badges to say things like influenza, research, Ebola, or other topics of interest for that particular person. They would then submit these, which would propagate the interest submitted event. Whenever this happens, we would always then move on to the next flow, which is to get the skills, and then display these skills so that they're available for the user to interact with again. And through this little flow here, we have connected the user in the UI through a service which is aggregating data from different sources, introduced a policy which is going to always run whenever this event is propagated, and always result in a new list being demonstrated or shown to the user. At which point then the user has now another opportunity to interact with the system now that more information has been made available for them and to be able to continue on their flow. Storm will generate a number of assets for us. The first and probably the most important one of these things is the group getting a shared understanding as to all of the bits that are involved in designing and building a new system. It will also give us a number of things that are directly translatable into work that we can do. In a residency, we will take all of these blue stickies, which represent actions or things to be done, as well as any experiment that's popped up via this command or experiment sticky, and we will put it into our backlog as it is work that needs to be done. Given that the team, such as the development team, the DBAs, the back-end engineers, front-end engineers, testers, whoever else is involved in the event storm, given that they are the ones who are helping to model this system out, they now have contextual awareness as to what each one of these blue stickies means. Another key thing that we get from an event storm is the number of systems and aggregates of other systems that we need to implement. And these are almost directly translatable into something like our architecture. So from this, we can pull out all of the components and build out our architecture, getting the traceability as to where it came from as we build it out. So in this example, we have our LXP connected to the course service, the topic service, and the profile service, all of which were discovered via the event storm.
Brilliant job, Donal. Thank you so much. What an awesome practice, event storming, so popular here in labs. And of course, one of the reasons we use event storming is because the logical architecture starts to emerge out of the event storm. And to tell us a little bit more about the practice of emerging architecture, we're going to go back to Jorge in Spain, who is our senior cloud consultant.
Hey guys, so now I'm going to be talking about a different practice called emerging architecture and how it is linked with other practices, especially dev and storming. So we call it emerging architecture because we don't design it up front. We just produce enough architecture to deliver the part of dev and storm that is being developed during a sprint. This architecture evolves over time, sprint by sprint, and following Agile and DevOps principles, it starts providing value from the very beginning. So let's take a closer look into one.
So let's deep dive into an emerging architecture example. But first, let's see how it is connected with the event storming. An event storming is a visualization tool borrowed from the domain-driven design world. At the end of an event storming exercise, you probably will end up with a big canvas board like this one, with all the information of the different layers of the system you want to build. We will use some of the components discovered during the event storming as building blocks of our architecture. They are very likely to be turned into an external system, like a database or LDAP, or a microservice to be developed. So, let's talk about the emerging architecture. Here first you can see all the components that were discovered during the event storming. As you can see, they have dummy or funny names like Combobulator or dinosaur names. Teams tend to try naming them without fully knowing about them, so once you have walked through the flow several times, you will know enough information about those components to name them. Now we are going to see the evolution of an emerging architecture through 4 different sprints. One of the reasons I want to explain in the introduction is like we don't produce the architecture up front, but deliver just enough architecture to deliver the part of the event store we are developing in a sprint. So as you can see, we have an emerging architecture evolution during 5 sprints. During the first sprint, you can see there is just 2 microservices here with no meaningful names. In the second sprint, 2 more services were added. In the third sprint, you can see that the architecture is becoming more complex with more connections and more components. And finally, in the last sprint, you can see how all of them fit together. So this is a perfect example of how sprint by sprint the architecture is evolving. And that's it from my side. Back to you, Chris and Tim.
Fantastic. Thanks, Jorge. One of the common problems that our customers face is that time from asks to get. So from requesting the feature or the product to actually getting that running live in production.
Yeah, and we've had this really, really useful practice that we use with our customers, which helps visualize all of those steps and capture some key metrics around process time and lead time. It's called metrics-based process mapping. And to hear a bit more about this, we're going to bring in our UX designer who's based in the UK, and that's Darpan.
Hi Tim and Chris, let me walk you through metric-based process mapping. This practice enables us to demonstrate clearly how this makes a difference to our customer process. Metrics-based process map visualizes all the things that happen between a user and business stakeholders from initial stage of requesting a feature and that feature running into production and being used. As you can see in this picture of swim lanes, that represent activities like handovers between different parts of the organization and the team. With metric-based process mapping, each step captures the metrics such as lead time, process time, along with completeness and accuracy. This lean process helps build shared understanding and adds visibility that highlights any inefficiencies and identifies potential improvements. The key outcome is the simplification of the process in a number of steps and handovers, which gives us the information and visualization of reduction in lead time and process time along with greater accuracy and completeness. So, when can we introduce the metric-based process mapping? We can run metric-based process mapping anytime before and after introducing any new technology and practices. Thank you. Back to you guys.
Nice. Okay, so now we see where the problems are, where the opportunities are that we can address. But Tim, I'm looking to, how do we take those ideas and prioritize those into a backlog that we can then deliver on iteratively?
Yeah, so what we do is we look at all of the things that have fallen out of the impact map and the event storm and the metrics-based process map, and we start to visualize value. And we've got some practices that help us with that. So our engagement lead in Germany, Cassandra, is going to tell us about value slicing, building product backlogs, and executing sprints.
Hi guys, welcome to Germany. So, at this stage of the residency, we have a bunch of ideas and features we can build and deliver. Value slicing is where we take them from our discovery practices and prioritize them in order to plan and build our product backlog. What needs to happen now is to visualize and organize all these ideas and features and categorize them under the outcomes we want to achieve. We then group them into horizontal slices of value. The top slice represents the highest value, the most fundamental, indispensable, and necessary to achieve the residency outcomes. This is the way we can assure that we are delivering value early and regularly, refining and planning as we go. We then take the items in the top slice and place them into the product backlog. The product backlog is an ordered and prioritized list of everything that is known to be needed in the product, including its content, availability, and ordering. A product backlog, however, is never complete. The earliest development of it lays out the initially known and best understood requirements. The product backlog is dynamic. It is constantly changed and refined to identify what the product needs in order to achieve the outcomes of the residency. So every week, we pull the most valuable items from the product backlog to create a sprint and decompose the work down into low-level tasks. Sprints are made up of sprint planning, daily scrums, development work, daily stand-ups, and the sprint retrospective. Each sprint has a goal of what is to be built, a design, and a flexible plan for the build, the work, and the product increment. The work to be performed in the sprint is planned at the sprint planning session and is created by the collaborative work of the entire team. It determines what can be delivered in the increment from the forthcoming sprint and how the work needed to deliver the increment will be achieved. The input to this meeting is the product backlog, the latest product increment, the projected capacity of the development team during the sprint, and the past performance of the team. Brilliant.
Thank you so much, Cassandra. So now that we've seen how we discover products and how we continuously deliver products iteratively and incrementally, let's talk a little bit about technology. And for this, we're going to go back to Donal, our architect in the UK, who I think has got a big picture he wants to show us.
Thanks, guys. So why don't you come on over and we'll take a look at the big picture. The big picture is a practice that we use to show how code moves from a local developer's environment into an environment such as production. We have a number of boxes. So this black box here on the side represents the tools that a developer might have in their local workstation. And this box here, the big blue one on the outside, represents the cloud. Within that, we have a number of things. So let's take a look at our local. First, we have a number of tools and CLIs as well as editors that a developer must have installed locally in order for them to be able to interact with some of the components in the cloud, as well as to be able to build out our applications. In this example, the development team was building Node.js and Python microservices, so they have those runtimes and code editors available to them. The big green box on the outside here represents the cloud. There are a number of products that we're using off the shelf that run in the cloud, such as GitHub to store our code, as well as Red Hat Quay, which is where we will store our images once they're produced by the pipeline. The red box below it represents OpenShift, and this OpenShift cluster is running in Azure. For this customer, we had a number of tools which were deployed into the cluster. But before that, we divided the cluster up into a number of logical separations. These are known as namespaces or projects in the OpenShift world. We had a number of projects, including the CI/CD project, which houses our tooling, our Code Ready Workspace project, which houses the editors and the online tooling that we can use, our monitoring stack, and a dev, test, and staging namespace where we would deploy our applications. Each big picture will always have an icon or some representation of what the tool is and a one-line sentence to describe what it is, or more importantly, how the team is actually using it. So in this case, some of the key tools we had in our kit bag were things like Jenkins, Nexus, and Argo CD. So Jenkins is a CI tool that helps us to automate the build process. Nexus we use to host our binaries, as well as our Helm repository. And Argo CD, which is a declarative GitOps tool, and we use this to manage the deployment of our applications. That can be both the applications that support this process, such as our tools, as well as the actual applications and microservices that we're developing. We kind of subscribe to this notion of an abstract pipeline within the Red Hat Open Innovation Labs. And the abstract pipeline kind of follows this very simple convention. A build, followed by a bake, followed by a deploy, then we run some tests, and then we promote our application. So what does a build do? The lower level steps down here are the details, the implementation steps for each of our given frameworks or languages. So for example, the Node.js microservices, as well as the Django APIs and the Vue.js front end. But let's not go into the weeds on that just yet. Let's kind of focus up here on the high level view of the pipeline. So a build will always take our code and do some sort of compilation to it, producing a package. The next step in the pipeline is then to bake that. The idea is we take the package that was previously created in the build and we put it in a box. The build is also responsible for doing things like unit testing and linting and kind of the other non-functional static analysis that we might do on our code base. Once the object is baked into a box, it's now ready to run in a container platform such as OpenShift. We then move on to the next stage. The next stage is to do a deploy. In this case, a deploy simply takes the artifact that was created in the previous step and deploys it using Helm, packaged up with all of the services, routes, and other configuration, and deploys it into the test environment. So an application in a modern ecosystem is not made up of a single service, such as a monolith. It's usually made up of a sequence of microservices and maybe a front end connecting to them. In this view, we see our application as actually the sum of all of its products. So it's an app that's made up of all of these services and the front end and the persistent layer. And this kind of app of apps notation is what actually makes up the running service. So when we deploy a component in our architecture, so imagine for example here we update something like the skills service or the recommendation engine, we need to validate that the system as a whole is operating as we expect. So we run our end-to-end tests against the test environment. So if our test cases have all passed and they are successful, we can then promote our application to staging. This is another automated process, and the act in which we use to automate that is to just check in the updated revision into Git. Then a tool such as Argo CD can take the change that it's seen in Git and roll it out into the OpenShift cluster. A big picture is a really useful artifact as it helps to generate a shared understanding within the team so they can see how the tools interact with each other and how we can use them to our advantage. It also allows us to do some rapid prototyping. It's much simpler to play with a pipeline when a pipeline is only made up of a couple of stickies and a drawing. It also allows us to simplify complexity. People often generate very complex pipelines, whereas this big picture view allows us to see how code is moving across the ecosystem and into the various environments in one single clear view. And with that, it provides us an information radiator. Back to you guys.
That was brilliant, Donal. Thanks for that. I can really see how that communicates so well to the team about what's going on, but also for the wider stakeholder group to understand just how complex what's being done is and all the component parts. So whilst we're with you, have you got any other practices that you would like to share with us?
Yeah, guys, I've a couple more practices I think you might be interested in hearing about. So the first of these are pair programming and mob programming. So they are two engineering practices that we absolutely love to use on a residency. For those that don't know, pairing is a simple act of two minds solving one problem at the same time. So what we like to do is pair two engineers side by side with one machine tackling the same problem or trying to build that one feature. You're probably thinking to yourself, two people doing one person's job, that kind of sounds like a waste of time. But actually, it's a really, really great practice to use, and there's a number of major benefits in being able to do so. So the first one would be to mentor junior and new members of a team by seeing and doing and kind of observing the behavior of other people in the team. It really, really helps to accelerate someone's learning. Another great benefit to pairing is that we can do away with code reviews and kind of pull requests, as by doing things as two minds solving one problem, we're kind of implicitly reviewing the code as we go along. So we don't need to wait for this peer review at the end. And the other thing is that pair programming is really, really great team bonding. It really helps to retain all the knowledge within the team, so we don't have one superhero who knows how everything is formed. And so what about mobbing? Well, mobbing is kind of much the same. There's only one real difference, and that is that the whole team, instead of just two engineers, work on one problem. We use mobbing often to crack a new problem or to align the full team on a new thing. So for example, when the team writes their first microservice, instead of one superhero going off and doing it all by themselves, it's much more valuable to have the whole team contribute and share in this experience. So imagine they scaffold out the folder structure, they write the first set of tests, create a bunch of automation as one big team. This then accelerates future development as the whole team is now in sync on the approach to the software implementation. Pairing and mobbing is a bit of a mindset change, and we like to try and add the behavior of doing work in groups and pairs in this way to things like our social contract. If there's one thing I really love to see in a social contract, it's big phrases like, mob to learn or pair to build. I think they're really, really impressive to see. So this is a little video I recorded recently of a group of us from a virtual residency, all mobbing around one problem. So there were 3 engineers, and we were just after writing some features, and we decided to implement some tests. A tech practice that I think is super important is the idea of radiating information. As software engineers, we have tons of places that we can get feedback from, but some of those mechanisms are pull, not push. By creating software dashboards to show us our delivery metrics or perhaps the health of our builds, we can really, really improve the feedback loop for our teams. So one of my favorite things is a Jenkins build monitor. As a lazy developer, it's very easy for me to push my code and assume everything works without checking. But by radiating the progress of how my code is doing while it's being built, tested, and deployed, and then pushing that information directly to me, I can respond quicker and don't have to go searching out the information. It's not buried in some tool. This Jenkins dashboard is so simple but tells me so much information. For example, I can see what builds are failing and for how long. I can also see what builds are currently running. I can even add things like test scores or do some analysis as to why the build failed in the first place, and then have it displayed here, radiated to me. We operate a no-blame culture, but Jenkins here has also picked up who committed the change that fixed this build. In a residency, we would have dashboards like this one plastered all around the walls and on big screens, getting the information to the development team as soon as possible. The real secret sauce in a residency is connecting the technical team of engineers, architects, and testers directly to their end users and to the business. Having the team of doers, as I like to call them, collaborating directly in this way helps them feel more connected with the work that they're doing. It really helps to build a culture of ownership and pride in the work that's being done. Kind of living that mantra of you build it, you run it, you own it. So for example, imagine an engineer who works with the UXD team during a prototype or usability session. As they watch some of the functionality that they wrote being used firsthand, they begin to build empathy with that user. The next time a feature comes through that needs to be implemented, they can resonate with that experience and have it in the back of their head who this feature is being built for. They feel more connected to the product that they're building and can picture that person being happy that their feedback was acknowledged and then implemented. And this is the real secret sauce of the virtual residency.
Great, Donal. Thanks a lot. I can really see how we're using those practices really lays a foundation with the team and really keeps that sustainable pace, not just during the residency, but beyond. So we've seen some of the technical practices, Tim. What about the cultural practices?
Yeah, the technical foundation is really important, but the other key foundation that we need to lay during our residencies and virtual residencies is culture. And culture is such an important aspect that we need to get right whenever we're building high-performing teams. Now, in Open Innovation Labs, we have loads of little tools and practices that help us create culture and this environment of psychological safety, and we've adapted them for the virtual residency. And to hear some examples of how we've done this, I'd love to hear from Anna, who's our engagement lead, who's recently just finished a virtual residency with a large healthcare organisation and has got some great examples to share.
Thank you, Tim. It's been great fun adapting our practices and creating new ones to work remotely. As you say, our practices focus on driving the open organization principles that Shabs mentioned at the beginning. Our team culture practices specifically focus on collaboration, inclusivity, and building the psychological safety. And of course, having fun and a sense of belonging to something bigger. So how do we do it remotely? Let's take a look. So the team we worked with were due to come together, but then the COVID hit, so they had to switch to a virtual environment. Some of the team had literally just joined the organization. We were in completely different time zones, nobody knew each other, and we were at the mercy of everybody's broadband connection. We kicked off getting to know each other through a variety of icebreaker exercises. We ran them regularly to help pull us back to the importance of making the connection and to get everybody talking in the sessions. Just as an example, we used the superpowers practice to help people to get to know each other. What were they bringing to the team to make it better and open up about themselves to their teammates. From experience, we know how important it is to build a collective identity. It might feel like a nice to have, but it really drives the bond within the team, the desire to collaborate and to support each other as a team. For this, we collectively agreed on our team name, we designed and produced a team logo, and even created a team hoodie. Social contract is one of the key elements for the team culture, so we obviously had one too. One of the items that was ensure that everybody's voice is heard. This is really important as it drives that inclusivity and collaboration that we want, but it also indicates the psychological safety. We used our collaborative whiteboard tooling to measure the team sentiment. For example, we used mood marbles, weather windows, where the team members could reflect how they felt on the day. We also created a short selfie videos of their work environment, so everybody could understand where other team members are, and that really helped us to build the empathy within the team. Another super important part of our social contract was fun. We did not forget about it. We allocated some dedicated time for team socials. Every week after the retrospective, we played some joint games, we shared the takeout pizza, we even did an escape room. To be honest, we were not very good at escaping it, but we came together as a team and eventually we made it. Well, I guess it's much easier to live this amazing culture than explain it with words, but I do hope I managed to give you a little bit of a taste of it. So with that, back to you.
Wow, Anna, that was really fantastic. Really interesting to see how those practices have been adapted from the physical world to the more virtual setting that we find ourselves in today.
And you can learn much more about all of these practices and many more by visiting our Open Practice Library at www.openpracticelibrary.com/learn.
And if you'd like to find out more about the virtual residency, please book a one-to-one with us. We'd be delighted to hear from you.